Hello, and what this slideshow is going to be discussing is the results of a literature review on safety by design in the current literature as it relates to engineered nanomaterials. And what we're going to be doing is, after going over a brief methodology of how we garnered our literature review results, we're going to be going into different themes and analyses and ideas that are discussed throughout different sections of the engineered nanomaterial and safety by design literature, as well as a few selected policy documents that bring up core concepts of safety by design within the engineered nanomaterial space, both as a philosophy and as a method that can help further engineered nanomaterial development in the marketplace moving forward. Within our overall literature review process, we started with an initial subset of articles, and then we were able to filter out, after reviewing all titles, keywords, and abstracts, as well as different portions of the paper. We were able to narrow that down into a smaller subset of 317 articles, and then we added additional policy documents from the United States, European Union, and People's Republic of China that directly or indirectly focus on safety by design as an important concept or as a driver of safety by design and nanomaterial development moving forward. Within our coding and analysis, after we accrued our 323 articles, what we did is, after taking some descriptive statistics like the article's age and its citation count, we also added in an interpretive analysis that grouped each article into one of four categories. Number one, this is our basic or physical science, or articles that are exploring like the basic chemical, biological, physical properties of the engineered nanomaterial and how the authors of the study were seeking to identify or promote safety by design in the earliest stage of nanomaterial investigation. Number two and number three both talk about applications of those basic science breakthroughs in engineered nano. Where category two are those that are non-medical in application, and category three are those that are medical in application. The reason why we separate the two is while they all discuss the productization of engineered nano or the application of nano into different contexts, in the medical field, it significantly dominates, or at least is a large plurality of many applied publications from year to year. And we did want to be able to draw out the fact that there are many other different elements of safety by design, such as within industrial chemical and industrial products development and manufacturing, that were worth bringing out. And it's not only a medically dominated field. Although medicine is certainly very important, and we'll be discussing that in a few slides. Lastly, our fourth topic is social sciences discussion. So this moves entirely away from either the bench science work or the application of nanomaterials into products, and instead talks about their implications from a safety by design perspective. Regulation, law, governance, policy, economic, societal implications, ethics, and things like that. So once we have coded all of our articles, we then went through and again read each one to get an overall idea of what the core themes are, how they frame safety by design, how they discuss safety by design as something that can help or hinder the development of engineered nanomaterials moving forward in one country or globally, as well as just how can we better understand it as a core and developing science within nanotechnology development overall. So there are two core concepts that come to mind across most of the articles that we've surveyed. Number one is this notion that safety by design is framed as something that brings the concept of safety to the earliest stages of development in the engineered nanomaterial life cycle, where even in the research and development phase, and even in the basic science phase, the hope is that we can bring safety as a core concept, have the consumer, the worker, consumer, and the environment in mind. And as you progress through that life cycle, again, from research and development to manufacturing to shipping to consumer products to end-of-life disposal and environmental health and safety, it's how do we integrate different core concepts of safety early on, and that safety doesn't become something as an afterthought or as something that has to be addressed only as the product is ready for testing and evaluation before it reaches the marketplace. The second overall concept that is frequently discussed at a more technical level is how do we engineer out the undesirable effects of materials and products of engineered nanomaterials well before entering the marketplace. Like what are the strategies that we can do to better characterize and identify lesser understood hazards? How do we eliminate potential exposure pathways, particularly those that are for unintended receptors of risk? And then simultaneously, if exposure is very difficult to control or mitigate, are there different strategies that we can use to change the properties of the engineered nanomaterial or the product that it is placed within in order to limit the consequences of that exposure, the exposure to that nanomaterial hazard to a given receptor? So again, how do we actually engage in the engineering out of that process at each life cycle stage, and particularly the earlier the better for the greater cost savings. So if we unpack these themes, there are further three ideas that I wanted to highlight from several specific articles that were very well cited and had different perspectives on the two themes from the previous slide. The first item is that safety by design is intended to address safety in both the research and development and design phases of broader nanotechnologies. So what this quote is looking at here is that safety is not only something that after a product is developed, we then test the product for a variety of properties, toxicity, etc., to see is it safe to release to a given population or a given consumer within a given environment, but how do we integrate those notions very early on, even as a core regulatory theme? What are some of the regulatory requirements that, if they are instilled even in the earliest stages of material development, can reduce the burden of evaluation later on in the evaluation process? That second quote is, I'll just read it out. The common idea behind these different safety by design terms is to engineer these undesirable effects out of the respective materials or products, which entails that functionality and safety be considered in an integrated way from the earliest stages of research and development process. So similar to our second theme, again, that engineering out phase of how do we actually engage in the physical or bench sciences to better characterize hazard, to reduce exposure pathways, or third, reduce the potential consequences if exposure cannot be controlled. And then third, the way that safety by design is currently communicated tends to treat safety as an inherent material property, this is fundamentally problematic as it represents a recasting and reduction of societal issues into technical problems. Again, so I picked this quote because it was rather interesting in the way that it was grappling with the fundamental difficulty that many folks practicing or seeking to further safety by design have, whereas there isn't necessarily a simple way of addressing that engineering out problem and guaranteeing or safeguarding safety in the earliest stages of development, and that we do need to get back into looking at these core principles of measurable hazard, characterizable and identifiable exposure pathways, accessible consequences to nanomaterial risk, and advancing safety by design more than just a philosophy, but as a set of tools and benchmarks and gold standards that can advance the field moving forward. So overall, and again, I do want to point out this 2020 year is incomplete. It only includes about half a year, but we can see the field has grown substantially. The social sciences do seem to be leading the way, which is unsurprising given the fact that philosophically safety by design is very well rooted in a variety of different ethical, social, regulatory, and legal processes and pieces of scholarship for several decades now. But at the same time, many other components such as safety by design in bench science papers, applications in medicine, and applications outside of medicine have grown substantially as well, and this is likely to continue moving forward. Similarly, the citation counts have also risen. So while we do have the bulk of our citations being clustered roughly into our social science area, Our physical sciences papers do tend to show very outsized influence overall with their average number of citations, where we do have some articles that do appear to be gaining quite a bit of visibility, that they've become seminal papers. They're cited by an awful lot, particularly in the applied sciences, and it is influencing the field moving forward. So what we can take away from the citation counts is the field is maturing. We do have robust citation growth. There is a lot of acknowledgement and reading of these papers. And there doesn't seem to be any single field that tends to dominate that discussion and citations that is influencing safety by design discussion moving forward. And again, if we're just looking at how these articles are clustered, overwhelmingly, most articles tend to have 15 or fewer citations, but we do have a rising number that have greater than 50 that indicates that, again, the field is maturing and it is developing this core nexus of publications that folks tend to turn to for their safety by design inspiration and ideas. So some very quickly perspectives from the United States as well as China. Again, focusing on a few policy documents, they are very limited to direct discussion about regulatory challenges of nanotechnology and how they might be bridged moving forward. From the United States, again, there's some notions of promoting the design and development of safe and environmentally benign manufacturing and end-of-life processes for engineered nanomaterials and nanotechnology-enabled products. So again, with the consumer and with the environment in mind, how can we further develop nanomaterials to overcome regulatory quagmires and catch-22s so that nanomaterial products, when they do reach the stage of consumer evaluation by various regulatory agents, there's a lot less uncertainty to deal with and a lot less hazard that we already know is a problem, a lot less hazard due to the fact that those issues have been engineered out. And then third, from People's Republic of China. Again, there are different drivers of needing to institutionalize lean principles into nanomaterial research, where they're looking for a synergy among researchers in terms of new testing and characterization methods of nanomaterials alongside industrialization. So a similar perspective in some documents that we're seeing, and it's cited here. The discussion of safety by design centers on how do they integrate safety in the early stages of development to make commodifiable products that are more profitable in the long run and take less time due to risk-based evaluation to reach commercialization in a very safe and efficacious manner. With the notion being that if you engage in safety in the earliest stages of development and you are able to do that engineering out activity, you've already conducted quite a bit of that risk assessment for the regulator up front. There's always going to be uncertainties and things that get unpacked later on, but it does allow regulators and consumers to preempt many of these risks, and then hopefully able to not only bring products to the market that are safer, ethical, more efficacious all around, but maybe even a broader stream, an increased subset of products overall that would normally be stuck within regulatory quagmires due to uncertainty and concern related to hazard. So overall, just to conclude, safety by design as a concept has grown dramatically over the past several years. It doesn't necessarily have an established beginning, nor is it unique to nanotechnology. In fact, it does have quite strong roots in medical sciences and medical research, which, again, looking at how do we improve human health practices and the provision of medicine to people of all different ages and conditions so that they may have better outcomes downstream. So safety by design, not a new concept. It is something that is borrowed heavily from other fields, but it is growing rapidly to meet very unique challenges of engineered nanomaterials more specifically. Secondly is that we do have some concern related to tracking the political, institutional, and cultural frames of how safety by design is understood. Something that was brought up in different articles throughout the study is that safety by design can mean one thing to one industrial or national audience and something very different to another. Maybe it's a very strict standard to abide by. For another country, maybe it's a methodology. For another country, it's just a philosophical aim that should be striven for where possible. So if you're looking to develop a global norm or standard of safety by design, it's going to be very difficult to do that in the near term, and it's going to become increasingly difficult over the extended horizon as the field continues to grow and mature across different countries, both within policy and within academia. And then last, safety by design is often used as an aspirational philosophy rather than as a standardized process, although this is changing. Many of our early articles in safety by design and engineered nano were introducing the idea that you could deal with risk at the earliest stages of development. And then even within the bench sciences, there are processes that we can do to engineer out or at least sequester some components of hazard to make for safer products downstream. So this philosophy, while it is helpful, doesn't necessarily provide policymakers with the notion of how do we actually operationalize and institutionalize safety by design. And what we are seeing as a result is a increasing body of work that's looking at safety by design as a method or a tool that's across the life cycle of engineered nanomaterial development. There are things that can be unlocked and activities that can be conducted to basically instill properties of safety by design. It's never going to be perfect due to the fundamental uncertainty that we do have about many engineered nanomaterials, but we are starting to see that willingness to develop different tools, metrics, frameworks, and guidelines that policymakers can appreciate moving forward. So with that, that includes this presentation, and thank you very much for listening.